Welcome to the Explainer. Today, we're going to demystify the kind of complex world of drone building. We are going to give you the complete blueprint to go from just a box of parts to a fully functional flying machine. So let's get right to it.
All right, let's just kick things off with a question. Have you ever looked up, seen a drone just slicing through the air and thought to yourself, hey, could I actually build one of those? Well, let me tell you, the answer is a huge yes, and we're going to show you exactly how it's done.
So think of this explainer as your complete guide, your roadmap. We're going to cover the different types of drones, the core components you absolutely need, and of course, the programming that brings the whole thing to life. Okay, let's dive in. First things first, not all drones are created equal, not by a long shot. So before you go out and buy a single part, you've got to know what kind of machine you actually want to build. Understanding these main categories, it's the absolute first step in your journey.
The two most common types you're going to run into are fixed-wing and multi-rotor. Now, a fixed-wing drone is, well, it's basically a little airplane. It uses its wings for lift, which makes it super efficient for flying long distances. A multi-rotor, on the other hand, like the quadcopters you see everywhere, uses its propellers to just hover perfectly in place, and for VTOL, that's vertical takeoff and landing.
Now, if you're getting into more specialized tasks, you've got other options. Single-rotor drones. They operate just like a helicopter, which makes them absolute workhorses for carrying heavy payloads. And then you have these wild fixed-wing hybrids. They're pretty complex machines that really try to give you the best of both worlds. You get rotors for that vertical takeoff and wings for efficient long-distance flight.
Okay, so you've picked a type. Now let's get into the nitty-gritty. Let's look at the anatomy of your drone. These are the core components, the essential hardware that makes up the body of your flying machine.
You know, what's really fascinating here is how each part kind of maps to a biological system. The frame, that's your skeleton. The motors are the engine. But the real star of the show is the flight controller. That's the brain. It's making thousands of calculations every single second just to keep the drone stable. It sends signals to the ESCs, the electronic speed controllers, which act like the muscles, telling the motors exactly how fast to spin. It's really a beautiful, interconnected system.
All right, so you've got the basic components down. Now we can get into the really fun details. The next step is learning how to read the technical specifications. You know, the spec sheet on a product page, so you can choose the right parts for your build.
So, a really crucial thing you'll see when looking at motors is this number called kV. Now listen up, because this is a common mistake. This is not kilovolts. It actually stands for RPM per volt. It's a rating that tells you exactly how fast a motor is designed to spin based on the voltage you feed it.
And this, right here, illustrates the central trade-off. High kV motors, they spin incredibly fast. You pair those with small propellers for high-speed racing drones. Low kV motors, on the other hand, spin slower, but they produce a lot more torque. That allows them to swing these big, large propellers for heavy lifting or for that super smooth cinematic flying.
It's not just about motors, though. You'll also want to look at the flight controller's processor. A newer F7 or H7 is going to be faster than an older F4. Which just means smoother flight and more features. And propellers? You'll see these numbers, like 5x4x3, and it might look like some kind of secret code, but it's really not. It just means the prop has a 5-inch diameter, a 4-inch pitch, which is how far it moves forward in one spin, and 3 blades. Simple as... Okay, now for the part that powers, well, everything, the battery. Almost every single custom-built drone uses a specific type called a LiPo, or lithium polymer battery. And the reason is simple. They can deliver a massive amount of power really quickly.
So, the fundamental building block of every drone battery is just a single cell. One of these cells, which we call a 1S cell, gives you a nominal voltage of 3.7 volts. Think of this as our basic unit of power.
So when you see a battery advertised as 4S, it's not some weird tech speak. It literally just means it has 4 of those 3.7 volt cells all connected in a series. This multiplies the voltage, and it gives you a much more powerful 14.8 volt pack that can spin your motors with some serious authority.
So when you're picking out a battery, you're really just balancing 3 key things. First is voltage, or the S count. That's your raw horsepower. Then there's capacity, measured in milliamp hours. That's basically your fuel tank. It determines flight time, but it also adds weight. And finally, you have the C rating, which tells you how fast that battery can safely dump all its energy to your motors.
Okay, you've done the research, you've picked out all your components, and now you have a box full of parts. This is where the real fun begins, the assembly.
You know, the build follows a really clear logical order. You start with the skeleton, which is the frame.
Then you mount the motors. Now, the most challenging part for a lot of people is the soldering. This is where you make all those critical electronic connections. Just take your time here. After that, you install the flight controller. And then finally, you wire up all the extras, like your camera and your receiver.
The hardware is now completely built, but right now, it's just an inert object. It's kind of a high-tech paperweight. It can't fly without its software intelligence. This is where you connect it to a computer, you install the firmware, and you actually tell it how to behave.
Drones operate on this really fascinating scale of autonomy. I mean, at level 0, it's all you. You're doing everything. But as you move up the levels, the drone just gets smarter. Level 2 uses GPS to hover perfectly in place for a super stable video shot. Level 3 lets you plan an entire mission on a map for surveying. And then you get all the way up to level 5, which is basically sci-fi stuff, where onboard AI can navigate complex environments and avoid obstacles all by itself, kind of like a delivery drone in a city.
And the firmware you choose to install, it depends completely on what your mission is. If you want a high-performance acrobatic racing drone, you're going to flash something like Betaflight. But if your goal is an autonomous photography platform that can fly GPS waypoints, you're going to choose a more robust system, like ArduPilot.
So there it is. That's the blueprint. We've taken you from a simple collection of parts and specifications all the way to an intelligent flying machine. We've covered the what, the how, and the why. So really, the only question that's left is, what kind of drone are you going to create, and what are you going to teach it to do?